Veritomyx is applying high-performance signal processing and computing capabilities to mass spectral analysis. Our first software offering, PeakInvestigator, detects and deconvolves overlapped, nearly isobaric peaks, offering up to 10 times better mass and abundance precision in your spectral peak lists. One of the toughest challenges in mass spectral analysis arises when peaks are so close to each other that they are not resolved by the mass analyzer or software. By using PeakInvestigator software, you can effectively triple the resolution or more from your existing mass analyzer outputs. When overlapped peaks are undetected and a single peak is reported, longer and more expensive investigations are required for compositional identification. Inaccurate IDs can lead to expensive misdirection of R&D efforts and to missing important biomarkers completely. PeakInvestigator uses advanced signal processing methods with potent statistically powered capabilities for peak detection and deconvolution. More accurate peak lists lead to improved compositional identification and allow you to identify previously hidden peaks. This presentation will show PeakInvestigator's superior resolution and precision. It illustrates how PeakInvestigator is remarkably robust and easy to use. Most importantly, it will highlight how the improved resolution and precision can accelerate your compositional identifications and lower your R&D costs. PeakInvestigator software delivers a 3 to 4-fold increase in the effective resolution of virtually any mass analyzer. This improved resolution reveals overlapped peaks with up to 10-fold improvements in mass and abundance precision and better signal-to-noise sensitivity. Most importantly, these precision improvements accelerate the journey to correct compositional identifications. Precisely deconvolving hidden peaks moves their correct IDs up near the top of composition search rank listings. This means fewer incorrect candidates for investigation, saving precious time, samples, and resources. Furthermore, by deconvolving and identifying nearly isobaric ions that would otherwise interfere and confuse identifications, there are fewer false leads to validate in open-ended searches for differences between samples. Detecting and deconvolving previously hidden peaks also opens up a valuable opportunity to salvage new information from old data. PeakInvestigator is highly automated, reducing variability between users, instruments, and runs. The peak detection algorithms automatically adjust to fluctuations in instrument tuning, baselining, and thresholding are fully automated, requiring no user-adjustable parameters. Statistically powered, it is designed for 21 CFR 11 and HIPAA compliance upon commercial release, making it a natural choice for regulated activities. Multiplying the effective resolution of your existing mass analyzers also helps defer the timing of your next big mass spec investment in pursuit of better resolution. Let's dive into a specific example. What appears to be a single peak is often 2 or more overlapped peaks that are unresolved by the mass analyzer. This specific example was designed to demonstrate equal counts of 2 known compounds that differ in mass by less than 21 millidaltons and are unresolved at this analyzer resolution of just over 7,000. Conventional software solutions fail to detect or deconvolve such closely overlapped peaks. Cerno's MassWorks software models this as a single peak, with large mass precision errors versus the 2 known underlying components. Standard centroiding methods like MZMine similarly produce only a single centroid, also with large mass precision errors. PeakInvestigator correctly detects and deconvolves the hidden peak pair, providing up to 10-fold improvements in mass precision relative to the 2 known chemical identities in this example. In addition, note that the two known peak components are present in this sample at 250 counts each. When hidden peaks are missed, the centroid for the combined peaks substantially overestimates abundance versus the actual abundances of the components present. PeakInvestigator's precise deconvolution of the hidden peaks also delivers up to tenfold improvements in abundance precision relative to the two known species. Now, let's take the same peak pair that we have been examining into a compositional ID search using Mass Mountaineer software. The peak pair was not deconvolved by Cerno MassWorks or standard centroiding, and the large mass and abundance precision errors that result cause misdirection of the compositional searches away from the correct identities. R&D efforts that are misdirected by incorrect identifications can add expensive weeks or months to the investigation of lengthy candidate lists. Separation methods may need to be revisited before elusive hidden species are correctly identified and validated. The more worrisome outcome is when the correct biomarkers are never discovered. When PeakInvestigator deconvolves these hidden peaks, it vaults the correct chemical identities up near the top of the compositional search candidates list. A faster and more confident path to correct identifications is clearly an attractive value proposition. Let's make the challenge even tougher. We will look at an example with similarly tight peak spacing, just under 23 millidaltons, and we will add the complication of deconvolving peaks of different abundances with a dynamic range challenge of a 7-to-1 ratio between the actual abundances of the two known components. PeakInvestigator detects and deconvolves these two hidden peaks, again with remarkable precision. While the smaller peak, which is closer to the threshold of detection, carries more error, it is completely undetected and missed by other centroiding methods. While we have looked at some specific examples, let's now generalize the problem discussion to all mass analyzers. When dealing with overlapped peaks, it is helpful to frame the problem in terms of deconvolution resolution, which is a dimensionless variable that characterizes the degree to which nearly isobaric peaks can be distinguished at the resolution of any specific mass analyzer. Deconvolution resolution is a universal concept that applies to all mass analyzers. As the peak width at half height decreases, the mass difference that can be resolved between peaks decreases proportionally. Their ratio, which is deconvolution resolution, remains a constant for any mass spec operating at its resolution level. Peaks that are far enough apart to be resolved by the resolution of the analyzer produce deconvolution resolution values typically below 1. Peaks that have merged with no observable valley between them have a deconvolution resolution larger than 1. PeakInvestigator's advanced signal processing algorithms are able to detect and deconvolve peaks overlapped at higher deconvolution resolutions, reaching far beyond the resolution level provided by any mass analyzer. This concept is particularly useful when examining the highest value of deconvolution resolution, for which software can still detect and deconvolve the hidden peaks, which is the software's limiting deconvolution resolution. Here, we use limiting deconvolution resolution to compare the performance of the three software platforms across a dynamic range of peak height ratios, from 1-to-1 on the right side to about 7-to-1 on the left side. PeakInvestigator maintains at least resolution tripling performance across the full dynamic range. PeakInvestigator automatically establishes baselining and signal-to-noise thresholding on a locally adaptive basis. The baseline and signal-to-noise threshold levels determined by PeakInvestigator are typically lower than those set by visual estimation. This results in PeakInvestigator delivering more sensitive peak detection, while eliminating the tedious manual examination of spectra required for baseline estimation today. The statistically robust and reproducible methodology incorporated into PeakInvestigator is able to determine each peak assignment with statistical confidence. Here we examine PeakInvestigator's ability to detect and deconvolve overlapping peaks at different peak abundances relative to the background noise in the spectrum. At its upper limit, we see that PeakInvestigator can detect and deconvolve peak pairs at deconvolution resolutions as high as 4, with peaks so tightly overlapped that they provide no visual cue that a pair might be hiding there. We see that PeakInvestigator automatically established a limit of detection at a signal-to-noise ratio near 4:1. Expanding this analysis across many examples, we see that PeakInvestigator maintains its high deconvolution resolution performance down to a signal-to-noise level of 10:1. PeakInvestigator guides raw spectra through state-of-the-art algorithms that automatically adapt to differences in instrument tuning variations from day to day and between operators. Its automatic localized baselining and signal-to-noise thresholding removes the need for visual inspection of data before processing and manual estimation of centroiding parameters, eliminating yet another source of operator variation. The bottom line is that PeakInvestigator minimizes variability in results between users, runs, and instruments. It is built upon statistically valid and reproducible methodology and is designed for 21 CFR 11 and HIPAA compliance upon commercial release. PeakInvestigator's advanced signal processing capabilities are achieved through a combination of proprietary, state-of-the-art algorithms that are executed in a scalable, high-performance computing cluster to achieve timely and cost-efficient results. Accessing PeakInvestigator is incredibly easy using a simple API, or Application Program Interface, from your existing validated mass spectrometry workflow. For convenient, immediate utilization or demonstrations, we have incorporated the PeakInvestigator API into the open-source MZMine 2.10 mass spectrometry workflow software. This is available for download from Veritomyx as the MZMine PeakInvestigator edition. You simply import your raw LCMS spectral data into MZMine PeakInvestigator edition and specify PeakInvestigator for the data analysis. The embedded API will securely transport the file over the web to the Veritomyx high-performance computing platform. When PeakInvestigator analysis is completed, the results flow securely back through the API and are reinserted back into the MZMine LCMS workflow. In summary, PeakInvestigator triples the effective resolution of virtually any mass analyzer, or better, revealing hidden peaks with greatly improved mass and abundance precision, and delivering more complete peak lists. With automatic instrument accommodation and elimination of manual settings, it is particularly robust and easy to use. It generates reproducible results with statistical confidence, and it's an ideal fit for regulated workflows. But the true value of PeakInvestigator arises from leveraging its remarkable precision improvements into better compositional ID search rankings, greatly reducing the waste of precious time, samples, and resources in downstream investigations or in research misdirected by incorrect IDs. Better resolution produces better precision, which yields better identifications. PeakInvestigator's ultimate value proposition is more effective R&D that accelerates you to your objectives. Veritomyx. Ask us about integrating PeakInvestigator into your workflow.